Logistic regression is a classification rule we use when the outcome is binary, that is, the target class is either negative or positive. The big idea is that the logistic regression models the probability of a positive response p hat. Let's suppose that y is binary outcome and x is a feature matrix, which will look like this. The probability that the label of a given instance is 1 can be calculated using the matrix multiplication equation here, where betas denote parameters we have to find. Probability should lie between 0 and 1, but this equation will often yield a value greater than 1 or less than 0. So we need to transform it into a logit form, which is represented like this. In this way, we can get the probability of each instance being assigned to label 1. In the k nearest neighbor, or KNN, the class of each instance is predicted by the majority vote. Telling stories in pictures will be more intuitive. Suppose we have only 2 features, F1 and F2, and there are 3 classes, red, green, and blue. The instances in the training dataset are distributed like this. And here a new unseen data point comes in. In one nearest neighbor, the instance which is closest to the new data point determines the label of the new data point. In this case, a green point is the nearest one. So the label of the new data point is predicted to be green. In 3 nearest neighbor rule, the label of the new data point is determined by the majority vote from 3 nearest instances. In this case, 3 most nearest neighbors are green, blue, and green. So the class of the new data point is determined to be green by majority vote. Now we have trained models to predict whether a previously unseen document is classified into 0 or 1. The question is, how well do these prediction models predict a label of a document they have never seen before? How do we measure the performance of the prediction models? There are plenty of metrics we can use for this task, but today we will use accuracy and AUC. Let's take a look at the contingency table. When the classifier correctly predicts an instance as positive, it is a true positive. When the classifier correctly predicts an instance as negative, it's a true negative. But sometimes the classifier may make a wrong prediction. When the classifier mistakenly predicts an instance as negative when it was in fact positive, it is a false positive. And it is a false positive when the classifier mistakenly predicts an instance as positive when it actually was negative. Accuracy measures the proportion of instances that were correctly predicted as shown in this equation. As you can see in the case in the exercise, accuracy is not a good performance metric when it comes to imbalanced data. There are many more positives than negatives in the data, so you will achieve high accuracy even when you indiscriminately predict any instance as positive. To overcome this problem, we can employ another evaluation metric, area under the RC curve, or AUC. AUC is more representative of highly imbalanced data when it comes to predicting in previously unseen data. The AUC measures the area under the RC curve. The RC curve represents the relationship between true positive rate and false positive rate, or 1 minus specificity. In this graph, the red model is the best because it achieves a higher true positive rate at the same false positive rate than other models do. As you can intuitively see here, the larger the area under the RC curve, the better the model performs. A model is a perfect classifier when its AUC is 1. That is, the model can differentiate labels without making any errors. But a model with AUC of 0.5 is of no use. That is, the model classifies instances in a random manner. Let me just briefly introduce other metrics you can use to evaluate the classification performance. Recall measures the proportion of true positives among actually positive instances. In a text mining context, recall is the fraction of the relevant documents that are successfully retrieved. On the other hand, precision measures the proportion of false positives among true negatives. To conclude, today we learned about a feature selection method, chi-squared method, and two classification rules, logistic regression and KNN. We also covered performance evaluation metrics, accuracy, and AUC. That's it for the entire text mining module. To wrap up, we have covered various topics in text mining, including text preprocessing, exploratory analysis of text data, information extraction, feature representation for text, and predictive analysis. Many of the concepts you have learned in this text mining module, especially exploratory and predictive analysis parts, will be repeated in the data mining module. I hope you enjoyed the module, and this would be a great resource you can revisit to get future references over the course of your career.